Hello, my name is Lillian Cooper, and I will be doing my environmental case study on Seveso, Italy. Next, an overview of the incident. On July 10th, 1976, inside of a factory chemical plant in Mira, Italy, about 25 kilometers north of Milan, near the city of Seveso, Italy, there was an explosion at approximately 12:37 p.m. This occurred when a chemical reactor exploded in chemical plant B, releasing about 15 to 30 kilograms of 2,378 tetrachlorobenzopdioxine, also known as TCDD or dioxine, into the surrounding 18 kilometer squared area. The reaction was stopped before completion when the factory closed for the night and temperatures inside of the chamber rose to 300 degrees Celsius. The liquid was abnormally heated and the relief valve released about 6 tons of chemicals. In this cloud, there was sodium hydroxide, ethylene glycol, and sodium trichlorophenate. This cloud was carried southeast by the winds, contaminating the land and vegetation. The primary chemical we are concerned about here is 2378 tetrachlorobenzopdioxine, which is a byproduct of combustion for cosmetics and pharmaceuticals. This chemical is a known human carcinogen and endocrine disruptor that is highly lipophilic, meaning that it remains in fat deposits and has a long, stable half-life of about 7 to 9 years in humans. Bioaccumulation is a significant concern as the exposure can continue along the food chain pathway. Most of what we know about the effects of this chemical are from research done regarding this event. Symptoms to exposure of this chemical include neurological problems, infections, nausea, headache, eye irritation, liver function issues, immune and hepatic endocrine toxicity, and skin lesions, also known as chloracne. There were about 200 cases of chloracne, mostly in children in the area. There was a high mortality rate of plants and animals in the surrounding area. These dead animals, primarily chicken and rabbits, overwhelmed the city, and many were slaughtered to prevent people from eating them. Unfortunately, research was not begun until much later, as Hoffmann-La-Roche finally admitted about the explosion 1 week after the incident. By this time, many cases of severe dioxin poison were reported, and significant amounts of vegetation and thousands of animals had died. On July 25th, research had finally commenced. Affected areas were divided into 4 zones. Next, we have the table of contents. Initially, there was no individual biomarker available to test the TCDD levels. Many of the studies from Seveso relied on zones of evidence to classify levels of exposure. The first zone, Zone A, had the highest levels at 15.5 to 5,477 micrograms per meter squared of TCDD in the soil. There were 736 residents here who were evacuated and underwent immediate medical exams. In Zone B, there were 5,000 residents, and a proactive approach was taken as they were not evacuated but warned to avoid consuming local produce and poultry. These residents all received medical exams and lab tests, and pregnant women and children under 12 were periodically relocated out of the zone. Zone R was the least contaminated zone and had 32,000 residents who were also warned not to eat any local foods. The final zone is Zone non-ABR, where there was no TCDD detected in the soil and it was considered to not be exposed. Other communities nearby that were affected included Mira, Desio, Sisano, and Moderna. It wasn't until 1987 that the CDC developed a method to measure the concentration of TCDD in human serum. Overall, the median lipid-adjusted serum levels for the 1978 incident was 55 parts per trillion, but ranged from 2.5 to 56,000 parts per trillion. These levels were higher in Zone A, with a median of 272 parts per trillion, and less in Zone B at 47 parts per trillion. Those who were under 10 years old generally had much higher serum levels. We can see a map where the red part is Zone A, the orange part is Zone B, the yellow part is Zone R, and the bluish green is Zone ABR. In 1988, the CDC measured the TCDD levels in 30 archived blood samples from 1976 from 10 Zone A residents who were diagnosed with chloracne, 10 Zone A residents who did not have chloracne, and 10 non-ABR R residents that had confirmed exposure. When studying chloracne, there seemed to be no threshold exposure for it, and majority of cases were under 15 years old. The TCDD levels remained higher in 101 chloracne cases compared to 211 controls at the time of follow-up between 1993 and 1998. The chloracne risk was the highest in those who were younger than 8 years old at the time of explosion. The prevalence of chloracne in each zone was as follows. Zone A, 19.6 prevalence, Zone B, 0.5 prevalence, and Zone R, 0.7 prevalence. In addition, in 1996, about 20 years after the explosion, a historical cohort study was done with female residents who were newborn to 40 years old in 1976 in Zones A and B and had blood collected at the time of the explosion. This eventually became the Seveso Women's Health Study, which was funded by the NIH and the Lombardy region of Italy. The first follow-up was in 1996 and had 981 women who were mostly from Zone B. In addition, they also compared levels between those who were different ages at times of explosion, with most participants being 31 to 40 years old. There was a separate TCDD and total TEQ test from archive samples between 1996 and 1998 for women who reported a live birth between 1994 and 2009. These levels remained elevated at a median of 7.3 and 25.7 parts per trillion respectively, compared to those who were unexposed at a median of 1.6 and 18.1 parts per trillion respectively. Even 20 years later, the majority of those who were children during the explosion still continued to have elevated levels. There were about 943 live-born children born to 574 mothers during this time period. Age in 1976 at the time of explosion and sex were the strongest predictors of 1996 serum TCDD rates. As we can see, those under 10 years old with TCDD exposure, the chemical had a half-life of 7.1 years, while those who were 6 to 10 years old, their chemical had a half-life of 5.2 years, and finally, those under 5 years old, their TCDD levels had a half-life of 4.3 years. This is possibly due to dilution from growth and increased body mass at higher explosion doses. This elimination rate is likely dose dependent. After adjusting for additional covariant, the geometric mean of serum TCDD in 1996 was found to be 17.6 in women and 6.7 in men. The half-life in men was found to only be 7 years, while for women it was found to be 9 years. In regards to animals in the area, studies were done on rabbits by different zones, Zone A, B, and R. Zone A had the highest mortality rate at 31.9% of rabbits dying. Zone B was next at a mortality rate of 8.8%, and Zone R last at a mortality rate of 6.8%. 4% of domestic animals died in this area, and 99.64% of these were small animals. It's estimated that about 80% of the TCDD that came into the environment adhered to vegetation and was transferred to the soil via rainfall. They estimated that the leaching of TCDD was only to a depth of about 20 centimeters, and 50% of the breakdown in soil occurred within 9 to 12 months. Overall, this has been ranked the 8th worst disaster by Time magazine, and they found higher serum dioxide levels in Seveso zones could have resulted from inhalation of airborne fallout, thermal contact, and mostly ingestion of contaminated food. Causes of death in the subsequent years were mainly attributed to cardiovascular and respiratory diseases, citing a possible relation between the psychosocial consequences of the explosion. In addition, there are more instances of diabetes and an increased rate of gastrointestinal tract, breast, lung, lymphatic, and hematopoietic cancers. In 1983, 5 of the chemical company officials were convicted, but only 2 were found guilty of criminal negligence in this case. La Roche eventually paid $168 million in damages to cover decontamination, disposal dumps, and new housing for those whose houses were destroyed. Finally, we have our references.